Okay, good morning, grade 9s. It's Mr. Smith here. As you can see by the title page here, today is April 16th, 2020. And the purpose of this video is to help you specifically with the homework for week 2. Okay, so I'm going to demonstrate some questions this morning. I've taken them from your homework. I'm going to split it into 2 parts because you know that when I assign homework, there's sort of typically there's the practice questions, and then there's the applied questions. The practice questions are just you're just dealing with numbers. Usually the applied questions you're dealing with word problems. So the practice questions that just deal with numbers, questions 7D, 8D, 9B, 12A, I just took them from the textbook. Okay, so these are kind of freebies. Now for question 15, 16, 18, and 19, I'm not going to do those problems for you, but what I did was I made up my own problems for part 2. They're very similar. So I'm not going to solve question 15 directly for you, but I'm going to model a question that I made up that is pretty similar to 15. Okay. So without further ado, let's do part 1. Okay. I'm going to split this video, otherwise it'll be super long. Part 1, I'm going to do 7D, 8D, 9B, and 12A. Okay. Okay, so we're going to start with page 311, number 7D. All right, so what do we have here? We still have a two-step equation. Now, for some of you, I know that this may look a little bit complicated, where it's nicer when we live in sort of the kingdom of whole numbers. So let's say a whole number version of this question might be something like 4 minus 2r is equal to, it doesn't really matter. Let's go with -6. All right. In other words, we still have all the same parts as we do with the two-step equation. We have the part that is a coefficient attached to a variable. Here we have a constant. Yes, I do notice, and I hope you did too, that this is kind of backwards. So really, maybe we should switch the way this question is written up. All right. And then, of course, we have the answer. Now, typically, like the way the textbook explains it, usually you write the part with the variable comes first, and then there's a plus, or it could be a minus b, and then it equals your answer. So really, the proper way to write this question would be -2r plus a 4. Where did the plus come from? Because it's the sign on the 4, right? The -2, the subtract 2r now becomes a -2r. I'll say that again. The subtract 2r becomes a -2r, plus 4 is equal to -6. And this form looks a little bit more proper in terms of the way it's written. Okay. Actually, like if we went to our polynomial language, it's written in degree order. In other words, you have your variable listed first, your constant is listed second, and then of course your solution is your solution. Okay. I just wanted to show you that this structure, this two-step equation, is still a two-step equation over here. It just looks more complicated because you have fractions. Okay. So I'm just going to erase this now, and let's move on to our actual question. Okay. So erase, erase. So here's the first thing I'm going to do. I am going to rearrange. Okay. I like to have the variable, whoa. Okay, rearrange. That's supposed to be an n. So here's what we're going to do. We're gonna have these two parts flip places. Okay. So -2.5r plus, again, where did the plus come from? The plus is the sign that's attached to the 4/5. This is a positive 4/5, and now it can be read as adding 4/5. Okay, positive 4/5 is really the same equivalent as adding 4/5 is equal to 3/10. Okay, so notice I haven't taken any steps to solve this question. All I did was rearrange. All right, so that would be step 1. Now step 2 is, you might know from a previous video, I don't like mixed numbers here. So let's convert this to an improper fraction. 2 times 2 is 4, plus 1 is 5. So really, and the negative just stays negative. The quality of this fraction is to be negative. So just the just because we're converting it to a improper fraction doesn't change the negative quality. 2 times 2 is 4, plus 1 is 5, and the whole fraction stays negative. Okay. So we've got -5 halves r plus 4/5 is equal to 3/10. Okay, now we are finally, in a place where it's something that's workable. Okay, so what are we going to do? We've got to do bed mass, but remember, bed mass, that's an ugly looking D, that's better. You have to remember that we're doing algebra. So remember, this has to go in reverse order. Okay, you've got to deal with your constants first. You're adding and subtracting. So what are we going to do to both sides? Well, we've got adding 4/5. So let's subtract 4/5. Let's subtract 4/5 from both sides. Okay? So you got 4/5, subtract 4/5, and this 0 pairs itself out of existence, which is what you want. You're trying to simplify this equation to isolate for r. So you want to get rid of this constant. All right? It's no different if this was a decimal or a whole number. The point is you're adding or subtracting. In this case, we're adding, but you're adding or subtracting a constant number. We want to get rid of it. So we use the balance approach. Whatever you do to one side, you do to the other. And then you have this wonderful effect of, well, what do you have left on the left side? You have -5 halves r, and that's equal to 3/10 minus 4/5. Okay. Well, you know what has to happen now? When you're subtracting or adding fractions, you have to have a lowest common denominator. Okay? So I'm going to do that way over here. I've got 3/10 minus 4/5. Oh, that's not a very good looking 4. That looks like a T almost. Okay, so let's try this. 4/5. That's better. So to get a common denominator, you need to multiply these both by 2. Okay, because the common denominator between 10 and 5 is a 10. All right, so 3/10 minus 8 over 10, and that's equal to 3 minus 8 over 10, so that's equal to -5/10. All right, so what do you have here? -5/10. And again, some of you might be tempted, and quite rightly so, to reduce this immediately. And I'm a big fan of reducing as I go along. So what is 5/10? It's just another way of saying a half. The negative doesn't really affect whether you can reduce it or not. If it started out negative, it remains negative. You're just reducing. What are you doing? You're factoring out a 5 here. Divide both the top and the bottom. Divide both by 5. And you get a -1/2. So you get a -1/2. All right, so now I'm going to go up here. I'm just going to rewrite this. Now, this r has to belong somewhere. There's a couple ways of approaching this question. I'm going to choose to do it this way. -5r over 2. And I'm going to include a bonus video, a third part, where I show you multiple ways of doing this, all right? Because there are a couple of approaches. And part of the approach in grade 9 is to give you different perspectives or different points of view on how to kind of attack a problem. Because there's lots of ways to solve this problem. I'm choosing it to do this way, okay? So all I've done here is I've said, hey, R, you have to make a decision. Let's belong to somewhere. And when the R is right in the middle of the fraction line, I'm talking about this part here, then that means automatically and always 100% of the time, the R should be put up in the numerator. Okay? Now, there's a couple of interesting things going on here. Number one, if you have the same denominator, if you're left with a single fraction on the left and a single fraction on the right, you know what you can do if they have the exact same denominators and it's a simple expression on the left and a simple one on the right? And by simple, I mean a monomial and a monomial. There's no more addition or subtraction. You could cross multiply, right? You could cross multiply these two and these two. Or, you know what you get to do if they have the same denominator? You just get to ignore them. And you get to write this question out as -5r is equal to -1. Believe it or not, you get to do that. Now, I'll prove that to you in a minute here. Well, let's just keep going. So if you have -5 times r, you divide both sides by -5, divide both sides by -5, and what are you left with here? A positive 1r, okay? A positive 1r. And you have a negative divided by negative, that's a positive, and 1/5 is just 1/5. Now, in case you didn't believe me there, and you're saying, Mr. Smith, how can you just get away with ignoring these denominators? Well, let's do it this way. Let's actually cross multiply and see what happens. Okay? Let's see if I'm justified in what I'm doing. So let's cross multiply. That's one way of getting rid of fractions. So 2 times a -5r, so you have 2 times a -5r on the left. You can put it on the right as well. It doesn't, when you cross multiply, it doesn't really matter. That's supposed to be an r. And 2 times a -1, and you have 2 times a -1. So again, this is the part where I could say, well, why don't we just cross out these 2's? And you could. Crossing out the 2's here when they're written as multiplication is the same as crossing the 2's out here, right? Crossing the 2's out here when they're part of division. But nevertheless, let's just keep going. Let's say I didn't cross them out. So 2 times a -5r is a -10r, okay? And 2 times a -1 is a -2. Well, now we still have a similar expression to what we did over here, but now we got to divide both sides by -10. Divide both sides by -10. Okay, so this still reduces to a positive 1r. And here we have a negative divided by negative is a positive, and so you have 2/10. However, I think you can see where this is going. Can we reduce the 2/10? And the answer is yes, of course we can. All right, what goes into both? If we take our common factors, I can divide this by 2, and I can divide this by 2, and I end up with 1/5. Okay? And look, it's the same answer. It's the same answer. So again, if you get to a stage where you simply have a simple fraction on the left, like there's no other expressions here, and a simple fraction on the right, in other words, these are 2 monomials, you don't have to necessarily cross multiply if they have identical, and it only works if they have identical denominators. If they have identical denominators, you can just wipe them out. Okay? It's the same thing over here. When you cross multiply, you can kind of see that at this point, you could actually just strike these 2's out. Okay, I hope that helped. That was question 7D on page 311. All right, next question. So we have number 8D. Number 8D. Okay, number 8D. Wow. You know what I'm going to do? I'm going to show you a different method for doing this because I think you'll like it. I think you will appreciate the fact that there's a neat little trick you can do to just wipe the fractions out of existence. Okay? But first, let's do a little bit of a rewrite here. Okay? Oh, let me just switch to a different color. Let me just go back to blue because I think for most of you, you find the blue easy to read. Okay? All right, so in other words, we're going to convert, right? We're going to go from mixed numbers to improper fractions. I find they are easy to deal with. So 5 times 4 is 20, plus 2 is 22. And that's over 5. And of course, the fact that it was negative to begin with doesn't change the fact that it's still negative now. The conversion of mixed to improper does not change whether this fraction is negative or positive. If it starts off positive, it stays positive. If it starts off negative, it stays negative. In this case, it's negative. 5 times 3 is 15, plus 1 is 16 over 5. Okay, and again, that is also negative, plus nothing to do here, except really nothing to do there. I am going to put the G up here, and hopefully it'll become a little bit more obvious in a minute. All right, I'm going to pause here, and I'm going to set something up for you, and I'll be right back, okay? Just hang tough. Okay, everybody, we're back. And what I'm showing you here is I want to show you this little trick or technique that you can do with questions like this. All right, so I've paused. I'm just taking a break temporarily from this question. I want to show you something. Okay, let's say you have, I'm just going to show you one of the most elementary examples in the universe. Okay, so you have 1 plus 2 and it's equal to 3. What if I were to multiply both of these sides, both sides of the equation by 2? So let's do this. 1 plus 2 over here, and I've got 3. Boy, must be early in the morning. The coffee hasn't kicked in yet. Okay, and I have 3 over here, and I'm going to times it by 2. Okay, so you got 1 plus 2 is equal to 3, and 2 times 3 is equal to 6, and 3 times 2 is equal to 6. And we originally started with 3 is equal to 3. Now, it looks like, well, Mr. Smith, you changed the equation. Well, I did, but I didn't. In other words, as long as I do whatever I do to one side, I do to the other, right? I haven't changed the fundamental quality of this equation. In other words, this statement is true, is it not? 1 plus 2 is equal to 3. So just because I inflated this balloon by a factor of 2, it doesn't really change much. I know you're saying, Mr. Smith, but it went from 3 equals 3 to 6 equals 6. But the equal sign doesn't care. The equal sign is, too many people do not understand the reality of the equal sign. The equal sign doesn't care how big or small your numbers are, okay? It doesn't. All the equal sign cares about is whether something is true. Let me do something different. You could also deflate this. In other words, what if to the left side, I divided by 2? And to the right side, to make sure I'm, following the rules here, whatever I do to one side, I do to the other. Well, what's 3 divided by 2? It's 1.5, right? If you have $3, you split it between 2 people, they each have $1.50. Well, on top here, right, you should do your adding of the numerators, so you have 3 over 2, and that's equal to 1.5. And so even though you're tempted to say, but Mr. Smith, 1.5 equals 1.5, that's different from 3 is equal to 3, and that's different from 6 is equal to 6. This is the beauty of the equal sign. This is the wonder of algebra. The equal sign doesn't care how you inflate and deflate questions, okay? So if you have this question, and I'm just going to make some more room now, okay? I'm going to do a question with fractions now, okay? All right, so let's say you have this. Let's say you have 1/2 plus 1/4, all right? That's equal to 3/4, okay? 1/2 plus 1/4 is equal to 3/4. To put it in terms of money, here you have 50 cents. Here you have 25 cents. Okay, we're adding them. And what do you have? 3/4. Well, how much money is 3/4? It's 75 cents. Okay, that's supposed to be a cent. Let me just erase that. Sometimes I write beautifully, and then other times it's like I'm back in grade 1 and a total spaz. Okay, 75 cents. All right. So here's another way of stating this truth. Okay, I'm just going to erase the cents part now. I can pull off a neat little trick here. Let's say these were really complicated fractions. Let's say it was like 3/16 plus 12/21, and it's supposed to equal, I don't know what the answer to that is, but let's say it's supposed to be 39 out of 43. And you're like, oh my gosh, those fractions are like tough to deal with. Well, here's what you could do, all right? And I know I'm getting on one of my famous sidetracks, but trust me, you're going to like this little technique, okay? Have faith, grade 9s. You know what I could do here? I could blow this equation up by a factor of 4. Now, why did I choose 4? Because if I were to look at a lowest common denominator here, it would be a 4. So what happens if I were to multiply this by 4? Okay, I already know this statement is true. I know that 1/2 plus 1/4 is equal to 3/4. Let's figure out what happens when I distribute a 4 through this, okay? 4 times 1, so remember, 4 is the same as 4 over 1. So I'm going to multiply everything here by 4 over 1. 4 times 1 is 4. 1 times 2 is 2. So I've got 4 over 2. 4 times 1 is 4. And 1 times 4 is 4. Okay, this is a 4. All right. 4, remember when you multiply fractions, you're just multiplying straight across, right? 4 times 3 is 12. 4 times 1 is 4. Now look, what happens when I reduce? 4 over 2 is the same as 2. 4 over 4 is 1. And 12 over 4 is 3. Look what I have. My famous 2 plus 1 is equal to 3. In other words, I blew up the entire equation by a factor of 4. Okay, I'll say that again. The equation here, let me just switch colors just for a sec here. The equation here is like, I just blew this whole thing up by a factor of 4. And I made it something more workable. I changed it into, instead of 1/2 plus 1/4 equals 3/4, I changed it into 2 plus 1 is equal to 3. Now look, 3 plus 3 is the same truth as saying 3/4 is equal to 3/4. Okay, I know you might have trouble accepting this, but what I'm saying is you're allowed to do whatever you want. To keep this really simple, I'll say this again. You can do whatever you want to your equations as long as whatever you do to one side, you do to the other. Okay? So I'm going to pause and erase all this stuff now, and let's go back to our question. Okay? Hang tough. Okay, and we're back. So that little tangent, I hope, will be worth it because look what I'm about to do. So I've got fifths, I got tenths. You know what I'm going to do? I'm going to blow up this fraction. Here's what I'm going to do. Sorry, I'm not going to blow up the fraction. I'm going to blow up the equation. I'm going to multiply both sides by a factor of 10. In other words, I'm going to multiply this side by 10, which is the same as 10 over 1. I'm going to multiply this side by 10 over 1. Now, look what happens. I'm actually not going to do 10 times negative 22. I can reduce this already. 5 goes in there once, 5 goes in there twice. So really, I'm doubling this. Negative 44, okay, equals, and now I'm going to distribute this 10 over 1 through the whole thing. All right. Well, I don't need to multiply 7g by 10 because these two 10s will cross each other out. So I'm left with 7g. Now, I get to use this 10 again. Okay, just switch the color. The 10 is going to get distributed to this one as well. So 10 goes in there once. 5 goes in there once. I'll say that again. And 5 goes in there twice. So I'm only going to double this. So negative 32. Negative 32. Let's see if I can make a negative 32 proper. Plus 7g. Okay, so believe it or not, this equation is the equivalent of this equation. All I did was blow it up by a factor of 10. And because the denominator of 5 here and 5 here, it really only has the effect of doubling the numerator, and really it didn't affect the numerator here because what's the point of, I could multiply 7g by 10 and I would, yes, I'd literally get 70g, but then I'd still have 10 times 1 is 10. So look what it reduces to, 7g, right? If I actually took 10 and multiplied it to negative 22, I would have negative 220. But by the time I divide that by 5, right, because 1 times 5 is 5, I would end up with negative 44. Okay? So this is a little trick that you get to pull off if you want. If you don't, you can still deal with all the fractions. But whenever you have friendly fractions, and I mean that the 5s are friendly to each other and both 5s are friendly to the 10, they belong sort of a nice little multiple family of counting by 5s. You can just get rid of the fractions right away. So what are we left with? We have negative 44 equals negative 32 plus 7g. Well, working BEDMAS backwards, I'm going to add 32 to both sides. Add 32 to both sides. And what do I get? Nice little zero pair there. And no, grade 9s, I'm not freaked out because this is on the right side. I don't care that it is on the right side, right? There's no difference between saying 1 plus 2 is equal to 3 or 3 is equal to 1 plus 2. Doesn't matter. Negative 44 plus 32 is negative 12. 7g implies multiplication, so what's the opposite of multiplication? Remember, we're always undoing. We're always doing the opposite. Negative 12 divided by 7. Okay, whatever you do to one side, you do the other. And g is equal to negative 12 over 7. Okay, now that can be changed to a mixed fraction, so that would be 1 5/7 is equal to g. And if you really wanted to, you could divide this, right? You could say negative 12 divided by 7, and that's equal to negative 1.714. Okay? Okay, I'm going to pause it here, and we'll do the next question. Okay, question 9b. All right. Now we're living in decimal land. All right. Now we're going away from fractions and we're kind of playing with decimals. Okay. So again, we still have the basic two-step structure. Okay. Nothing has changed. So what do we have? We have a variable and it's over negative 1.2 and it's subtract. And we've got 6.2. Now, I'm going to do a complete rewrite of this question just because I'm predicting or guessing that some of you might feel comfortable if it's in a more familiar structure. So first of all, I'm going to have this switch places with this, okay? So we could say it's 6.2 minus r over 1.2 is equal to 0.38. And guess what? I can keep rewriting it if I so desire, okay? I can keep rewriting. In other words, do we want the variable at the front of the equation, the so-called front? Yeah, we could. We could put it as negative r 1.2. Now, again, just to be clear about something, this is a subtraction sign, and now that we're putting this part of the equation at the front, we have to acknowledge that the subtraction sign now becomes a negative sign, all right? And just in keeping with being consistent here, now this positive sign really becomes the operation of addition because they're switching places, okay? They're switching places, so the signs have to find a new purpose in life. What was subtraction now becomes the negative sign to the r. What was a positive 6.2 now becomes the addition of 6.2. That has to happen because we're switching the places. Okay. So what's the purpose of me rewriting it? Because most of you are really quite familiar in the skin of ax plus b is equal to c. Now, a can be positive or a negative, right? And this could be addition or it could be subtraction. And of course, your answer can be a positive c or a negative c. That's what the real structure is. But a is a number, b is a number, c is a number, and of course, x is your variable. All right? Let's not get worried or freaked out just because it's division, right? So some of you may be noticing it that, hey, Mr. Smith, isn't this really x over a plus b is equal to some number c? And the answer is right. Yeah, this is the actual structure of this particular question, all right? The coefficient of r happens to be a divisor or a denominator. Okay, doesn't change really the strategies. Guess what we have to do? We have to deal with the constant first. So we're going to subtract 6.2 from both sides. 6.2. Now, that 0 pairs itself out. And what do we have left on the left side? Well, we have negative r over 1.2. Now, what is, just to grab my calculator here, what is 0.3? So 0.38 subtract 6.2. We've got negative 5.82. Okay. Negative 5.82. That's an 8. Okay. So what are we going to do now? Well, we could say, look, why don't we could cross multiply, or we, again, just with simple algebra rules of undoing, right? Remember undoing. What does this operation imply? It implies a division. What's the opposite of division? Multiply. So can't we just multiply both sides by 1.2? And the answer is yes. Yes, we can multiply both sides by a 1.2. So multiply both sides by 1.2. So basically we have negative r. All right, so this 1.2 is going to cross out this 1.2, right? 1.2 over 1.2 is still going to knock this down to a positive 1, which is what we want. So we have a negative r is equal to, and now let's drag our calculator back. And we're going to multiply this by 1.2. And that's equal to negative 6.984, okay? Negative 6.984. Okay, negative 6.984. Okay, are we done? No, we're not done. Okay, because we're not supposed to solve for a negative r. This is a problem. Okay, this is a problem. Okay, so negative 6.984, but it's a very, very simple problem to fix, okay? All you're gonna do is when you solve for a negative one variable, which is not what we're supposed to do, we're supposed to solve for a positive one variable, all you gotta do is multiply both sides by negative one, all right? So we're gonna multiply both sides by negative one, all right? Negative one times a negative r just gives us now a positive one r, and a negative times a negative flips us to a positive. So essentially the signs flip, really, that's what it comes down to. And you have r is equal to negative, or r is equal to positive 6.984. Okay? All right, so that is page 311, number 9D. Okay, the last one for the practice questions is from page 11, number 12A. So here, I'm just going to switch back to blue. Okay, comparison maybe to the last three, maybe you'll find this one a little bit straightforward, although I think some students, sometimes they get a little wigged out because they see this 0.074, which is a small, relatively small number. But guess what? This is still a two-step equation, right? It still has the basic parts. It still has this a, x, in this case we're minusing a b, and we're equaling a c, okay? Don't get bedazzled by the fact that your A's and B's and C's, because they're numbers, maybe fractions or decimals with 3 decimal places. It's still the basic structure, okay? In AX plus, or it could be add B, equals C, guess what? You still deal with the constant first, all right? This is always done last. This number that is attached at the hip to the variable, this number which is a coefficient, to use the proper term, the coefficient of your variable is always dealt with last. So what are we going to do? We're going to add 3.4 to both sides, okay? Add 3.4 to both sides. Okay, so this, of course, has this lovely effect of zero pairing this out, and you have 0.074D on the left. And let's just grab the calculator. Drag it over here if the calculator will cooperate. Thank you. All right, I don't expect you guys to do this the long way. Essentially what you have is 0.707 plus 3.4, and that's equal to 4.107. Okay, so 4.107. All right, so now what are we left to do? Okay, again, I'm saying structurally speaking, this part of the equation, this is no different from saying 3x is equal to 12, right? It's just that this one is very friendly from a mental math point of view. Okay, you guys know that it's x, or it just seems like the steps are so straightforward. Mr. Smith, why don't we just divide both of these by 3, and x is equal to 12 divided by 3, and x is equal to 4. Well, it's the same procedure here, all right? Remember, you're allowed to use a calculator at this point, so I'm making this argument that I don't think this is any more difficult than this question over here. Because if your calculator is going to do the calculating, then I don't think of it as a big deal. That's a 0. So in other words, just like we divide both sides by 3, we're going to divide both sides here by 0.074. Divide this by 0.074. And guess what? 0.074 over 0.074, that still makes a lovely 1. Okay? Which is what we want. In other words, they reduce to 1, and we're just left with D. Now, let's drag the calculator over here. And let's take our answer now and divide it. You see how it says, as soon as I hit the divide button, I'm giving you a little tip because all of you are going to be using this calculator next year. We take the answer, the previous answer, and we're going to divide it by 0.074. And that equals 55.5. All right? 55.5. 55.5. Okay. All right. That's the end of part 1. I know this was a long video. I'll put the index in the YouTube description so that if you want, you can skip ahead and fast forward to any question you want to review. Okay, I'll give you the time index, the time marks of which each question starts. All right. So we'll see you in a few minutes because I'll do part 2. I'll do the word problems. All right. Take care, grade 9s.